So in a large IC engine subject, we have to talk everything and every aspect. So for that particular reason, I have to open my Chitragupta copy. So here it is. So actually here it is. All right. So I actually cover all of this one by one. All right. So waiting for the first one. So as I already told you, the IC engine, that is internal combustion engine, is basically two type. One is a basically auto engine. One is basically the petrol engine. Another one is a diesel engine. The petrol engine basically run on the auto cycle. So here it is auto cycle, and the diesel engine basically run on the diesel cycle. But modern diesel engine basically run on the dual cycle. Why the modern diesel engine run on the dual cycle? Because the compression ratio of the diesel cycle, it is a very high. So because of that, they have a initial starting problem, initial fuel consumption problem, and initial we can they have a not initial, actually they are also have a like the scavenging issue, auto ignition problem. Due to the auto ignition, simultaneously they are also perform like the knocking tendency will be there. So to avoid that particular phenomena, we basically go for the diesel cycle. So if I talk about the practical cycle, in a theoretical cycle, the theoretical cycle we achieve the 100% efficiency, but in a particular the practical cycle, or in a particular real life engine, we do not obtain the 100% efficiency. Why? The main reason is that they have a loss. As I told you the earlier, Kelvin Planck statement, he basically say that we never ever convert the 100% heat energy into the work. There are always some losses. So due to that particular losses, we cannot 100% convert the heat energy. And this is, and now so this is a few in the technical term is like the scavenging, detonation of the knocking. Simultaneously we have the pre-ignition, that is also known as the advanced ignition, the auto ignition, the supercharging, turbocharging, and we also have a lags. So what is the scavenging? I talk about the first scavenging. So as you see here in this diagram, so this is the top dead center, this is the bottom dead center, and this is the basically the piston. And the scavenging is happen due to the high compression ratio, we can say. High compression ratio. What actually happen when the fresh charge or the fuel will be get into the engine cylinder due to the suction stroke? So engine will be feel that particular the fuel charge, and so initially during starting time, in a particular suction, what actually happened, the piston is moved from the top dead center to the bottom dead center. So piston will reach into the bottom dead center, and into the bottom dead center. But into the now you the piston, it is difficult for the piston to compress that particular the charge, because the initial pressure, that is also we can say the mean effective power, the mean effective pressure, and we can see the mean effective. Right now I talk about the mean effective pressure. So mean effective pressure initially very low. So because of that, the piston are not able to compress the charge properly. So we need to supply the more air fuel ratio into the, or we can say the more technical term is a chemically rich mixture we supply into the engine cylinder. And as the chemically rich mixture came into the engine cylinder, and the sparking will be take place, and because of that the burn gases will be generated. And simultaneously you know that the mean effective pressure will be less initially. Because of that, the engine and it's not and simultaneously the pumping power is also the less. So because of that, the piston is not able to remove the burn gases into the engine cylinder from the engine cylinder properly. So there have a possibility that any type of the burn gases which be present into the engine cylinder, and if the burn gases will be the present into the engine cylinder, then those burn gases are actually create a contamination of the fresh charge. And once the gas is getting so this particular, and we have to remove the burn gas from the engine cylinder. So this removing phenomena from to remove the burn gas of the engine cylinder, this particular thing is basically known as the scavenging problem. So the scavenging, in fact, if I have a two-stroke engine, so there we basically use like the cross flow and the back flow. And in a four-stroke engine, we basically send the compressed air to remove the burn gas. So this is basically the scavenging problem. Now we talk about the knocking. So in this particular diagram, the compression, if the compression high compression ratio, what actually happened? The pre-ignition will be start happen. The engine into the engine cylinder, the what actually into the engine cylinder, the pressure will be very high, temperature will be very high. So when due to the high temperature and pressure, if the fuel particle came into the engine cylinder, so the burning will be automatic started. So this is automatic one. This is the one burning will be started simultaneously due to the sparking. Another burning will be take place. So due to when the two burning will be take place, so flame the two flame are generated, and these two flame will collide with each other. It create a one type of massive vibration. So these vibration are inside due to this particular vibration inside the engine cylinder, we get a massive amount of huge pulsating noise. This will be produced. So this phenomena is basically called the knocking phenomena. So knocking phenomena. Okay, so now I talk about how we prevent this particular knocking phenomena in a petrol pump. When you go in a petrol pump, you basically observe there have a normal petrol. All right, another one is a premium petrol, another one is extra premium petrol. So this is basically the quality of the petrol. So this quality basically depend upon the one thing. For a petrol, it basically depend upon octane number, and for diesel is depend upon certain number. All right. So in a petrol pump, you see that they have a normal petrol, normal premium, and extra premium. So there have a huge difference of the fuel price. The normal petrol, it is belong to the less price. The premium, it is moderated, and extra premium, it is high in cost. So these quality of the petrol actually depend upon the octane number. For petrol, it will be depend upon the octane number. For diesel, it will be depend upon the certain number. So what is the octane number? Octane number, it is basically the rating system. It is basically the rating system. It is basically the rating system, and based on their anti-knocking properties. This octane number itself have the anti-knocking properties. So this is a rating system based on their anti-knocking we talk about the octane number. Then octane number is equal to the isooctane plus n-heptane. Alright, so isooctane, we basically take the help the 100%, and n-heptane will be take the help that we take that zero reference. Alright, so if a normal petrol, there have a isooctane will be the 70, and if the isooctane will be the 70, then n-heptane will be the 30, but we assume the n-heptane will be the 0%. All right, because it is actually the negative, not negative actually, because it is neutral in quality, neutral in its property. All right, and so and less in price. And in a normal petrol, we have a octane number belong to 70 to 75, and a premium 75 to 85, and 85 extra premium 85 to 95 or 97. It is belong to the extra premium. So this is what the octane number is. And a certain number, if I talk about a certain number equal to n certain plus alpha methyl naphthalene. All right, so here basically we take the n certain will be the 100%, and we take the zero reference of that alpha methyl naphthalene, and the remaining is the same thing. All right, so this is how we can avoid the knocking phenomena. Simultaneously, the compression ratio, we also take care of the compression ratio as well. Simultaneously, we also supply the chemically rich mixture, chemically lean mixture, according to the fluctuation of the engine speed and the load, which is further controlled by the throttle valve, and which is basically these chemically rich mixture or chemically lean mixture actually generated by the help of the these are basically dependent upon the equivalence ratio. So what is the equivalence ratio? Now here we get a particular term that is known as the equivalence ratio, as you see here, equivalence ratio. So equivalence ratio itself basically say that the chemically the correct means how many actually, so from this inlet manifold the amount of fresh charge came into the engine cylinder. So so this one divided by chemically correct air fuel ratio. So amount of fresh charge came into the engine cylinder to the amount of fresh came into the cylinder to the chemically correct air fuel ratio. So what is the chemically correct? As I told you early videos, in this particular diagram, and how carburetor will be operate. In this particular diagram, you basically see the how to prepare the air fuel mixture. So this particular air fuel mixture is known as a charge. So this is the working phenomena. Actually, this is the working phenomena of the carburetor. Actually, okay, how carburetor will be operate. So this is actually technical term is basically the charge. So this particular amount of the fresh charge came into the engine set. This amount of fresh, how much amount of fresh charge we came into the engine set, this is to the chemically correct. So this we have a particular ideal particular charge. So ideal chemically charge is basically 14.5 is to 1. So this is basically the ratio. So 14.5 it is basically the air, and 1% is basically the fuel. So if the chemically the chemically rich mixture means we basically supply the less amount of air, means 10 is to the chemically rich mixture. That time we can say less amount of air, like 10 is to 1. So this is, and the lean mixture, that time we basically provide the 15 or the 17 is to 1. 17 is the air and 1 is basically the fuel. So this is all about. So this is basically the knocking tendency, and simultaneously the auto ignition into the engine cylinder. What actually happened, that in this particular diagram you see observe into the engine cylinder, the temperature and the pressure is very very high, and due to that particular high temperature and pressure, when the fresh charge came into the engine cylinder, it get burned, and another burning will be happen due to that particular if I talk about the SI system. So due to the burning will be happen by the help of the spark plug. So the two flame will be produced, and when this phenomena, the fuel molecule will be started automatically burning due to the massive heat and the pressure into the engine cylinder. So this phenomena is basically known as auto ignition problem. The supercharging and the turbocharger, so it is a little different. Like if I talk about if I draw a particular engine cylinder itself, so if I talk about the supercharging, so in this particular diagram you see so here the turbocharger, this diagram is actually belong to the turbocharger. So I first use the turbocharger. So here due to when the burning will be take place, then exhaust gas are basically eliminated from the engine cylinder by the help of the exhaust valve through the exhaust manifold. So this is how the exhaust gas will be the flow. So when the exhaust gas will be start remove from the engine cylinder, so before removing from the silencer tube, it just rotate the turbine. All right, so this is basically turbine, and turbine is further connected to the shaft, and shaft is further connected to the compressor, and compressor is start rotate, and through the compressor is further connected to to the particular carburetor. All right, so carburetor, from the carburetor the fresh charge will be came into the carburetor. So before the compressor is actually compressed that particular air fuel ratio, and compressor actually the compressed mainly air. Now we have a basically FI engine. So FI engine we separately use the fuel, separately we use the fuel. So in a particular FI system engine, we basically use the turbocharger engine. All right, so in a motor vehicle you see the turbocharged engine. So the air is basically compressed by the help of this particular compressed compressor, and then compressed air goes to the inlet manifold to the engine cylinder. So this is how it will be operate. So this is the turbocharger is mainly we see in a FI system engine. All right. So now the the supercharger is actually we have a particular here we have a particular compression. This particular compressor is further connected. This particular compressor further connected to the crankshaft. So when due to the power stroke, the crank will be start rotate, and when the crank will be start rotate, from the crank, we take the power from the crank to rotate that particular compressor. So that what actually happened there are mechanical losses. So to overcome that particular loss, we basically built the turbocharged engine. So this is all about the supercharger and the turbocharger. And if I talk about the lag, so the what is the lag actually? Into the there are two type of lag. We have an injection lag and the ignition lag. So what actually happened into the engine cylinder when the fresh charge will be came into the engine cylinder, means when the piston will be start moving from the top dead center to bottom dead center, and after compression will be happen in a compression, so piston basically move from the bottom dead center towards the top dead center. That time basically fresh charge came into the fresh charge will be compressed, and when in a after compression stroke, the sparking will be take place. But here in that particular time the sparking will be not happen. So when the piston will be start moving down from the top dead center to the bottom dead center, somewhere the 15 to 20 degree below to the top dead center, that time the sparking will be happen. So this is basically known as the lag. For SI engine, it will be known as a ignition lag, and for a CI engine, it will be known as an injection lag. All right. So this phenomena, so it create an impact on it basically create an impact on the power loss. Okay. So this is how it will be operated. So this thing will be done. The next will be I talk about the the brake power, indicate power, and the efficiencies, the governing system, and all. The next video.